Hey Baker family, this is Miss Winston, your 8th grade science teacher. I'm here to talk to you about waves and some of the definitions behind waves. So let's get started. So the first thing I want to talk about is, and here's my doggo, he's just hanging out, is that there are two main types of waves. Those types of waves are mechanical and electromagnetic waves. And the reason why they're two different ones as opposed to just being called a wave is because one requires a medium to transfer through, which means it has to have a material. And then one also has to have or one doesn't have to have it. So they can travel through vacuums, which means the absence of material, the absence of space, or space, I guess. So the two are different in that manner. I know there are realistically 3 types of waves, and then those types of waves are then changed into 2 types. But for now, all you need to worry about is mechanical waves and electromagnetic waves. So let's talk about some of the definitions that go with mechanical waves and electromagnetic waves. So the very first thing we're going to talk about is, I'm going to go here, and we're going to talk about the baseline, or the line in which the wave starts. So this is the baseline. This would be your medium or your baseline if you have an electromagnetic wave. So you can measure the frequency, amplitude, anything that has to do with that particular wave. Most people, when they think of mechanical waves, they think of water. They think of ocean waves. And so because they think of ocean waves, you can think of this baseline as a flat pool of water. And as such, being a flat pool of water, you start to make some waves, right? So here is your wave. All right, let's make the wave bigger. Here is your wave in the water, or the vacuum of space. It's your baseline. This is called a medium, the medium at which the wave travels through. The idea that the wave has to travel through this medium, through this material. So the material is called a medium. And remember, electromagnetic waves do not have a medium. So the first thing I'm going to talk to you about is this here. This here, the very top of your wave, is called a crest. And the crest is measured by the baseline all the way up to the very top of your wave. And the next definition, and let's put some text in here, that way you guys know. Just make it smaller. This is called the crest. Oh, why gotta do that to me? Okay. So this is called the crest, the very top of it, and this is called the trough. Should probably double check that spelling, shouldn't I? Because if you guys know me, and you guys do, I am a terrible speller. T-R-O-U-G-H. Yes, good. Yay! And so the trough is the bottommost part of the wave, which is right here. And that's measured again from your baseline to the very bottom of your wave. So that is 2 definitions. You've got crest, the very top of the wave, and you've got trough, the very bottom of the wave. And then you have your medium, which is this line here. Oh, I'm making a hot mess now. Your medium. But okay. Think of, when you think of medium, think of those people who claim to speak to the other side. Boogers, it went off my thing. It's okay. So medium, I'll put those definitions at the end, or maybe I'll cut them into the video. So the medium is the thing that the wave travels through. You've got the crest, which is the top of it, the trough, which is the bottom of it, and then you have to have some sort of measurement of one wavelength, right? Because then we go into speed and amplitude and frequency of a wavelength. And so the measurement of a wavelength, and let's put wavelength here. The measurement of a wavelength is from, oh, where did you go? Wavelength. Okay, it stayed. The measurement of a wavelength is defined as one crest. Let's make it a different color, that way you guys can understand. Let's do purple, you know, or pink. One crest to one crest, okay? So it's the distance of the wave that goes this way, okay? That is a wavelength, crest to crest. You can also go trough to trough, or you can go baseline, crest, trough, baseline. And I will undo this so it's not so messy. And actually, oh, there's no eraser on this. Okay, and then you can go wavelength, which is the measurement of this to this. Okay, so you're measuring this length. It should be the same as crest to crest or trough to trough. They should all be the same measurements. If you're looking at the same wave, it should be the same measurements. So you can either measure it crest to crest, you can either measure it trough to trough, or you can measure it baseline, one full crest, one full trough, back to the baseline. So you have that ability to measure it that way, and that's how you measure a wavelength. The next thing, and let's undo all this. The next thing I want to talk to you about is what we call amplitude of a wave. And what the amplitude of the wave is the measure, it's basically the trough. Okay? So it's the measurement of a trough to when it is the baseline here, your resting position, right? Where your medium started before it happened. So this is your amplitude. Okay. The amplitude of your wave determines a lot of things about it, right? It could be how much energy goes into it, how far the particles have moved. So basically from the baseline to the crest is how you measure the amplitude of a wave. The next one is going to be frequency. And let's see how I'm going to make frequency. Let's undo amplitude. So frequency is how often the wave occurs. So it's basically, a lot of it has to do with the speed of occurrence, right? So if we take the same line, right, and we put let's put double. Let's double, whoops. Let's rotate it, eh? So it makes a proper wavelength, right? There we go, 180. So these two waves are different in frequency. It's how often the same wave occurs over and over again, right? So for instance, this one wave occurred only once in this same amount of time, right? Same amount of time. Same amplitude of wave, only there is now 1, 2, 3 total waves in the same distance, right? So in the same amount of time or same amount of distance, depending on what you're measuring, is the amount of frequency the wave, right? So the frequency, it hits whatever it is that you're measuring. So we have, just a review, we have the crest of the wave, we have the trough of the wave, we have what a whole wavelength is, and we have that the amplitude is a baseline or the medium set wave rate, right? So the original calm material from baseline to crest is a amplitude, and then frequency is how often that particular wave happens, right? So same wave because it's got the same amplitude, but the frequency is more, right? It happened more times. And I think that's all for the definitions. Trough, wavelength, crest, amplitude, speed, medium, mechanical, and electromagnetic. All right, yep, that should be good. So that will get you to the first part of the project, in which you are making a window pane of each of the definitions of the of a wave. So I will make another video. It'll probably be on electromagnetic waves, because this one was mostly on mechanical waves because it required, I was talking a lot about mediums. But electromagnetic waves are very similar, except for they don't require a medium. Thank you very much. I'll see you guys later.